So, good morning, everyone. Thank you for attending this second day of the IT Professionals Conference. And this session is the DNS and DHCP infrastructure at UW-Madison by Tim Sherwanka. There will be time for questions at the end. Feel free to drop them in the chat as they come to you, and we'll keep track of them or hold them to the end. Either way, up to you. Tim is a network engineer with the UW Division of Information Technology. With over 25 years at the university, he has served in a variety of roles, from system administrator to network engineer, and maintains a deep fascination with infrastructure in all its forms. Outside of work, Tim enjoys tinkering with electronics and building projects in his woodworking shop. And with that, I'll go ahead and hand it over to you, Tim.
Okay, thank you very much for the introduction, Dave. Thank you, Shay, for helping with the other technical stuff this morning. And thank you to everybody who's attending. Today, I'll be presenting a high-level overview of the DNS and DHCP services here at the UW campus with a little focus on how they're architected. In doing so, I hope to share with you some considerations for resilience and operational simplicity that we have in mind. As Dave mentioned, I'm Tim Sherwanka. I'm a network engineer here in DeWitt Network Services. Specifically, I am in the wide area network group. There are quite a few of us in network services who have active roles in supporting services like these, but generally, I guess I would be considered the subject matter expert for the services as provided by Infoblox. We'll get to that in a little bit. I know I've worked with a lot of folks, and it's fun to see the names populating in the list here on campus for specific DNS and DHCP issues. And I really do enjoy working with all of the people in the different departments to see what they do and how things are done, and to sort of, get towards the mission of the UW and get things done. Generally, if it's a migration or any sort of Infoblox request like that or anything out of the ordinary, it's going to come to me. So some of the topics that I cover today will be new. Some of them will be complete review for a lot of you, but I hope you come away with a few new things. I'm happy to take questions at the end, or if I see something, say something completely egregious in the middle, please stop me and we'll take care of it. To ensure that we're all on the same page, DNS, Domain Name System. It's the service that translates names from like wisc.edu into an IPv4 address like 144.92.9.70. It's easier for a computer to do that than people to remember it, obviously. DNS you can think of as a very globally distributed, highly available database of sorts, but with a lot of replication and a lot of delegation involved with that. DHCP, Dynamic Host Configuration Protocol. It's a way that your device can get an IP address starting with nothing to be on the network. In many instances, things like your phone and your laptop will sit on the network, send out a broadcast, a DHCP discover out into the local network segment. But the interesting thing is at that point, your host does not have an IP address that can be routed. So we often talk about the DHCP helpers needing to be set on the routers or the Palo Altos. That DHCP helper service is what takes that broadcast and gets it over to the DHCP servers so that the rest of the protocol can function and you get an IP address or a lease for a few hours, and you can get on with the network. There are a few other things in the protocol to avoid address conflicts, but generally that's about what happens there. DNS and DHCP don't always have to be talked about in the same breath, but with Infoblox and even with ISC, there are some conveniences to talking about them at the same time, but you don't have to. There's this construct in Infoblox called a host address, which sort of has a single pane that ties everything together with regard to that. DeWitt Network Services. So what is our role? DeWitt Network Services, there are about 50 of us, give or take, that not only provide the network connectivity for many of your devices, but some of us also ensure things like these DNS and DHCP services continue to function and just work. And a lot of that is not just making sure the power's on, but it's monitoring, capacity planning, security considerations, and with that goes patching, configuration, upgrading, migration, um, purchasing issues, things like that. And info blocks. When I talk about info blocks, that is just the name of a company that sells DDI solutions. DDI being DNS, DHCP, and IPAM. I just gotta love acronyms, full of acronyms. Um, anyway, on the UW-Madison campus, we use Infoblox appliances to serve the authoritative DNS requests and DHCP for wired clients. Uh, Before Infoblox, campus ran ISC bind and ISC DHCP to serve those requests. If you needed a change and you were using campus DNS or DHCP services, you emailed Hostmaster and you waited for that request to get serviced for everything. Otherwise, if that didn't work and you were maybe a smaller department, you ran your own larger groups, other groups would run their own DNS and DHCP services to take care of things, themselves. So, a little bit of history. After a lengthy project and RFP in the 2015-2016 timeframe, UW-Madison chose Infoblox among many other options as a replacement for the central DNS and DHCP services. Uh, After significant preparation and getting ready to migrate, it went live in January of 2017. Some of the goals of the Infoblox project were to streamline DNS and DHCP maintenance, enable campus departments to maintain their own zones in a central system rather than have their own infrastructure, to provide API access, implementing DNSSEC, talk about that in a little bit, and also to increase redundancy to support continuity of operations. So I think that the project has delivered on the goals of enabling a lot of departments to turn down their local DNS and DHCP services and independently maintain their records within the Infoblox environment, both via the GUI and via the API. Infoblox has relatively good role-based access controls and relies on campus manifest groups for authorization, and we use SAML for authentication for single sign-on. And we will provision non-person users for API access, so you don't need to stash your local NetID credentials or anything like that. With future versions of Infoblox, I was just in a feature preview yesterday. There may be some other options for authentication other than password authentication for the local users. But anyway, always something new that I look forward to. At the moment, a lot of people are using API access to do to automate SSL certificate renewal. So that's kind of a useful thing that has just come up pretty prevalently across a lot of groups and departments within the last year, I would say. UW-Madison implemented DNSSEC in 2021, and by maintaining additional hardware at a data center hosted by Rutgers in New Jersey, we can maintain DNS services even if UW-Madison were to become available and go offline. So we'll first talk a little bit about authoritative DNS. Typically, the way that a DNS client works is that it will ask a resolver. We'll get to the resolver part in a minute. It'll ask a resolver for the address of a host or service. It doesn't do all the work itself. If the entry is not cached by the resolver will recurse from the root server all the way down to the authoritative source. So let's consider something like wis.edu. The top level servers are a well-known list of servers for these recursive clients that point the resolvers to something like the edu top level domain servers. The edu top level domain servers, and there's quite a few of those, will then point your recursive client or a recursive client towards our list of servers, and there are 4 of them. These 4 servers, the authoritative ones, answer globally for all of our records under wis.edu. 2 of our servers are located in our Dayton Street data center. They are on separate sources of power. We have a third a third authoritative DNS server located in a different part of campus in another data center. And a fourth one is located, like I said, at a data center in Rutgers in New Jersey, along with a secondary Infoblox controller um, that would allow backup control if there were issues here in Madison. Some groups still do maintain their own DNS and DHCP services on campus. That's just yet another delegation in the string. And in that case, our authoritative servers just say, go look over there for the name of the next server to query. And if a department has delegated name service, then the availability and the correctness for those records are up to the folks who maintain those servers. So I talk a lot about wisc.edu, but there are actually over 3,700 DNS zones within the Infoblox environment that we support. 1,600 are the reverse zones for mapping the IP addresses back to the names. About 1,800 are actually third levels and fourth levels under wisc.edu. And about 200 of them are DNS zones not under wisc.edu that are directly related to functions. For example, WPR, we are authoritative for Wisconsin Public Radio for their DNS services. So getting to the recursive DNS, while our authoritative servers answer questions about our data, the recursive servers determine information about everybody else's data. Most clients, like your laptop or your phone or your computer, don't perform this recursion all the way from the root to the host address on their own. They rely on the resolvers to do this. On the UW campus, we have two well-known IPv4 and IPv6 addresses, 144.92.254.254 and 128.104.254.254. I won't recite the IPv6 ones. You can plug those in yourself if you need them. Those are actually backed by 4 servers on the UW campus. Additionally, these 2 addresses and our recursive servers are limited to only UW-Madison IP space for access. So the 4 servers are, those 2 addresses are served by 4 servers using something, and these are ISC bind, these are not Infoblox, using something called DNS Anycast. Sort of a simplified network diagram here. The 4 servers are directly connected to campus core routing infrastructure at 2 of our supernode sites. And these pairs advertise their shared address to the connected routers. In the case that either server in the pair goes down for any reason, they speak a routing protocol with the router itself. And if they go down, the route's withdrawn and the other server receives all of the traffic. So ideally, your client will have both of the well-known addresses configured, and protocol-wise, if either of these address works, resolutions should proceed. Speaking a little bit about DHCP, there are 2 Infoblox DHCP servers located in separate data centers on the UW campus. Both of the DHCP servers receive all of the DHCP requests, and the load is normally balanced between these 2, with either server capable of supporting the entire load and all of the requests. Infoblox itself sees tens of thousands of clients across the UW campus. And as a result of people doing work, there are frequent changes, relatively frequent, to the contents and the MAC addresses and the addresses being served within here. And we average about 80 requests per second on any given day, with the exception of misbehaving clients. And you can kind of see we've got some graphs here. We have a steady state that I expect pretty much all of the time of about 80 requests. We get some peaks and then we get some BART heads, which are misbehaving clients. And in the case of those, I'll see them on the graph, and if they're not egregious, I will find them. I will send email or try to contact the group in question behind those and say, hey, you happen to have a server that's asking for a request every second. Would you like to take a look at that? Because I would expect not every second for hours on end, but maybe once every couple hours. But anyway, just another time to enjoy working with folks on campus and meeting new people. Uh, so Infoblox, like I said, only serves wired DHCP. Due to the massive scale and to ensure reliability, wireless DHCP is served from a completely different environment using ISC's Kia. Wireless DHCP sees over 100,000 clients on average with very few server-side changes and averages about 300 requests per second. The lower graph, you can see that the requests per second from wireless is significantly different than the wired client behavior. There's seasonality with different class periods and also some peaks during the week and not as much on the weekends. But in both cases, the servers that serve these requests are redundant and also in different data centers. So part of having a resilient service is not just redundancy in the protocol, and redundancy in the hardware, but also I think includes monitoring. Number-wise, authoritative DNS sees 200 to 500 queries per second on a normal day. Recursive DNS sees 2,000 to 8,000 queries per second on a normal day. We have seen in excess of 140,000 queries per second for hours on end as a result from one random department's misconfiguration. And that being said, we're pretty well provisioned with the hardware that serves up recursive DNS. This was not a service impacting thing for us. And I noticed it. I contacted them and said, hey, you appear to be doing something a little bit odd. Would you like to investigate this and figure out what it is? And one of the advantages of being well provisioned with hardware is that if you know that you're not being service impacted, it gives them an opportunity to investigate, determine what's going on, and fix the problem so it doesn't happen again. So the question is, how do you know if it's not impactful? Well, it's the monitoring. In network services, generally speaking, if a server or a service or a router or a device on the network has a protocol or a statistic exposed that we can monitor, we will do so. Typically, everything is monitored with a 1-minute cadence and placed into a time series database, and we keep that data for as long as the device exists, and then in some cases, sometimes a little bit longer. Of those metrics that we monitor, we have thresholds on some of the important ones that will place alerts in front of the NOC operators to alert us for things that might be going wrong, and some other lower level things that are just a little bit less interesting that will email us in daily reports to take a look at. And you've seen some of the graphs that I'll take a look at and say, maybe I should ask these people what's going on. In addition to that level of monitoring, the recursive servers also do their own internal testing. If a recursive server cannot query itself, or the query takes too long on average over a certain amount of time, that server will pull its own route and restart the services, and in the process send a ton of alerts, because this is not normal, to the NOC and to also some of us in network services. Because as I said, it's okay for a DNS server to not answer at all. It is not a good thing for a DNS server to accept a request and not reply back with anything. So I think everybody has seen the internet meme that ends with "it was DNS." That being said, sometimes it is, but we do strive for redundant and resilient services. But sometimes things do happen. To some extent, the resiliency of the protocols and the redundancy help out a lot. But when there's a problem, how do we go about solving it, and then what? So these are a couple of things that we've experienced over the last several years that have been notable, and a few things about what I've learned and what we've done a little bit differently. So DNSSEC, talked about that a little bit earlier. It's DNS security extensions. DNSSEC is not encryption. but rather DNSSEC is a signature on the record that you ask for, produced by the server to indicate that what you asked for is actually the record that was intended by the authoritative server to prevent any man-in-the-middle modification of these records. Um, the on the other hand, it also provides proof of non-existence. If you ask for a record that does not exist, it will prove that that record does not exist. Um, the failure for misconfiguration in DNSSEC is basically that the resolver will return to your client no such domain. It does not exist. You basically disappear. Uh, DNSSEC is at this point not super prevalent on the internet because I think in part DNSSEC configurations can be a little bit tricky and the consequences for screwing up are relatively severe. That being said, we went ahead and implemented DNSSEC in 2021 for WIS.edu. At that time, the University of Michigan was a DNS secondary for us, providing the equivalent service of what we now have as ADNS4. They were the fourth site. Upon implementation, we found out pretty quickly that their server did not support the NSEC and RSIG records that were required for DNSSEC to work. As a result, approximately 25% of the queries for WIS.edu uh, resulted in, no such domain, you don't exist. That's problematic. So as always, with these sort of, big changes, always have a rollback plan. And once you have a rollback plan, I like to have metrics for at what point you're going to actually go ahead and execute that rollback plan. There's a little bit of debugging that you might take advantage of during that, but at a certain point you have to go back. So in the instance where DNSSEC did not work for us, we did roll back. We reevaluated what had happened based upon debugging information that we had during the time, and ended up deploying hardware, our own authoritative DNS hardware, out to Rutgers to resolve the issue. ADNS4 went offline. So about a year ago, ADNS4 went offline for several weeks. A routine Sunday or Saturday morning info blocks patch, part of that was to restart the server. And unfortunately, ADNS4, located in New Jersey, did not want to reboot. The Infoblox appliances are really just server grade hardware, but it's even with server grade hardware, things happen. This was a Saturday morning, and Infoblox had replacement hardware to us like early that next week. But even though I still had to prepare the hardware to ship to New Jersey, and then I had to ship it to New Jersey, found out that the folks in New Jersey work a little bit differently over their winter break than we do. I think we're pretty active with doing things, and we're around. For those guys, they're pretty much gone. Uh, and in addition to that, their data center is not located near their campus, so had to sort of ask and to convince them to, maybe make an exception and get the stuff over there and ask Smart Hands to get it in place for us. But because of the nature of the DNS protocol, clients just continued to use the three good servers, and there were no problems as a result. They got it in place, it came up, and it's working as expected at this point. So the takeaways from that is there's really no good time for DNS maintenance. But what I do have is the knowledge of that our lowest load for DNS is approximately at 5 a.m. any given day. So that's when I do the work, even if it's not expected to be impactful. And for this sort of failure, there really is no rollback. If the server doesn't boot, it's not going to boot. So the best that we can do is to understand how that affects things and to minimize the impact. And of course, leveraging the redundancy and the DNS protocol reduced the impact of that problem for us. So DNS attacks, there's there's two notable kinds that I'll talk about: DNS amplification and resource exhaustion. DNS amplification, if you can spoof an address on the internet, you can cause open DNS resolvers to send tons of answers to poor clients that didn't ask for these results in the first place. And if you're running a recursive resolver out on the internet and this happens, congratulations, you are participating in a DDoS attack. Um, it's one of the reasons why our resolvers are not open beyond the UW address space. It's also one of the reasons why it's a great idea to not have Active Directory-based DNS servers available on the public internet. So while they may be authoritative for their own content, they also happen to be recursive for their own clients. It can be a bad configuration. Um, Resource exhaustion. If you ask for DNS, if you ask for garbage from a DNS server fast enough, you can potentially cause an outage by trashing the cache or overwhelming the server resource limits. For us, again, recursives located are restricted to campus. If there's problems on campus, I can probably find who's causing the issue. For authoritative, we are very well provisioned with the hardware. We also have other tweaks like rate limiting facilities, and the UW has also on-premise and in-cloud Radware DDoS scrubbing appliances available for us that have some DNS-specific capabilities. And sort of the takeaway for this is that it's always a good idea to optimize for the worst case, not the operating situation. I need to be able to serve all of the requests, even on a bad day, and also to monitor the service and document the break glass procedures for some of these. Uh, I'm a I might know how all this works at 10 a.m. on a Tuesday, but wow, if the NOC calls me in the middle of the night, I sure hope I can rely on the documentation that I wrote when I was a smart guy, because it won't be in the middle of the night. Um, Contacts. If you, we have a spot in the KB, kb.west.edu/DDI. If you have document suggestions, I am all ears. Normal campus DNS and DHCP requests can go to Hostmaster, kind of like they have been in the past. And if you have infoblox specific information that you would like, send it to infoblox@lists.wist.edu. That's monitored by myself and a bunch of other folks in network services to make sure that you get an answer. And once again, if you have any other targeted questions, you can feel free to contact me via Microsoft Teams or email me, tim.shawanka@wist.edu. So with that, that is the end of my presentation, and I would be happy to entertain any questions.
Thank you, Tim. We've seen a couple questions in chat. The first one is, do you analyze DMARC records? And curious to hear about your tooling and processes around that.
I do not analyze DMARC records. DMARC records, while they are in DNS, are more, in my opinion, a function of things that should be reviewed by the the uh, the mail team for correctness and potentially security. We don't dictate what the contents of those records should be. And as far as what we, let's see, yes. So if you like to remember IPv6 addresses, there they are. And what do we use for monitoring? We have a homegrown system called, one of our other network, one of my colleagues wrote, called FIDO, that does a tremendous amount of SNMP polling. We also have other custom pollers that will produce metrics from various things and put them in time series databases. As we have been doing monitoring for a long time, we are using RRD, which I think was available well beyond things like Prometheus and these other, you know, current time series databases. But we, in some cases, have well over 10 to 15 years of data on long-running services, so we continue to use it. And as far as displaying some of the statistics on campus, we have some internal tooling, and we also use Grafana for displaying that.
Excellent. I would love to just ask you a bunch of questions all day. I've asked you a bunch of questions through email before, and you've definitely helped me with some infoblox stuff. But unfortunately, it is time to wrap up the session. So thank you, Tim, for
Thank you.
that.
Thank you for
And
joining.
yeah, thanks everyone for joining. Our next session will begin in about 10 minutes.
All right. Have a great day, everybody.
Thanks.